Right. Good evening, everyone. So today we have to do a second part of the revision, right? So what we're gonna do today, we're gonna do a revise about. I mean, actually, we did a revision about the history part, right? We talk about the scientist and cathode rays, right, and then gold foil experiment, those things, right? So today you can do another tute, right? So which is related to that part, and few basic things in chemistry, right? And I'll try to do the revision and some calculations related to waves, electromagnetic waves, right? What are the parts? So in under electromagnetic waves, so we have some calculations related to Planck constant and that wave particle duality of the matter, right? So those are the parts I'm going to try to discuss today, right? So let's try to do some calculations of that part also. So as the beginning, I'll already send the tute, right? I already upload the tute, right? So I guess you already at least did the first parts of that tute. Okay, so I'll start from the first one. Actually, don't don't think these questions will come to the exam, right, direct, right? The most of the time you will get some question related to scientists, right? The first MCQ, as I said, from the first week, right? So these are the basics, right? So here, so therefore don't expect these kind of questions, right? So here actually from the beginning, right, I actually first second months I always try to fill the gap, right? I always try to fill the gap between O levels and A levels, right? Because there's a huge gap in between O levels and A levels. Okay, there's a huge gap. Therefore, we do the parts related to A levels, and at the same time I always try to fill that gap, right? Therefore, sometimes we do some questions little bit lower than A levels and the same time in A level related questions, right? So here these are kind of a basics, right? Basics in chemistry, okay? So therefore don't expect these things in A levels, right? Okay. Right, clear, I think it's clear, right? Okay, so the first part of the paper, so let me show it a little bit, right? You already have that paper. Let me show it. This is the first part, right? This is the first part. Okay. Very basic things, right? What it asks: how did Rutherford interpret the following observations made during his scattering experiments, right? During his scattering experiment. So it asking, right? Actually, as I said again, don't expect these things in A levels, right? A level exam. These questions for get the idea, right? To get the idea, right? That's it. Okay. So most particles were not appreciably deflected as they passed through the gold foil. What is the conclusion, or what did he interpret, right? So the conclusion of that observation, right? The most of the area in the atom is empty, right? Therefore, almost all the alpha particles are just go directly through the atom, and some of them are scattered, right? Very rarely it's go back, right? But most of the time they just go like this, right? So what is the observation? This is the observation. So what did he interpret? He said most of the area of the nucleus is empty, right? Most of the area of the nucleus is empty, right? Okay. That's the interpret for the first one. And then the B, a few particles were deflected at very large angles. Few particles were deflected at very large angle. That means the nucleus, right, which is positively charged area, is concentrated to the center of the nucleus, right? What different would you expect if beryllium foil were used instead of gold foil in the scattering experiment? In beryllium, you have more nucleus, right? Therefore, you can expect more atoms, right? More atoms in the same area, right? If you consider some area, you can expect more atoms, therefore more nucleus. Therefore, we can expect more scattering, right? Because more, I mean, if there are 5 nucleus, let's say, consider the area that has 5 atoms of gold, but if you place the, if you replace it, if you try to replace it beryllium, right, there are more atoms, right, the same area. Therefore, we can expect more scattering, right? So no one did that kind of practical, right? So that's the idea. So I'll discuss it quickly, right? I mean, these are kind of easy, right? So the second one, so they show the experiment, right? What is this experiment, Lamai? This is the way they found what? This is the way they found, I mean, actually they separate radioactive, right? I mean, this experiment done by Rutherford, right? So he explained there are 3 type of radio, I mean, particles, right? Radioactives, right? So the alpha, beta, gamma. Those are particles, right? These are emitted by radioactive substances, right? These particles emitted by radioactive substances. Okay. So there are 3 particles. One particle is bent more, right, towards the positive plate, right? Positive electric plate. And blue one bend more. The red one bend a little bit lower. Then yellow one doesn't bend, it just go through the charge plates, right? No any changes, right? No movements. Okay, I mean, it's moving, but I mean, no changes, right? No changes in the direction, no deflects. So the idea, if it's deflect, it should have charge. If it's deflect, it should have a charge. If it's deflect, it should have a charge. That's the logic, right? So here there are 2, according to that, there are 2 beams that has charge, right? So beta rays, so it mentioned beta rays are negatively charged. Okay, so then the red color one, it should be positively charged. Why? It's bent towards the negative charge. So the theory, why these beta particles bend more and alpha particles bend less, the reason, just think about force, right? I mean, if this plate, I mean, yeah, force and the mass, right? If something heavier, if something heavy, you need more power, more force to change the direction. But okay, look at here, beta rays bend more. That means beta rays are lighter, right? Beta rays should lighter. Why? It's bent more towards the plus plate, and the red color one, beta, bend less, right, than beta particles, because beta particles are heavier, right? You already know beta particles are electrons. Beta particles made by electrons, and alpha particles are what? Alpha particles are H E 2 plus 4 2, huge atom, right? Those are helium atom, the full helium atom, right? So what are the main subatomic particles make up the atom? Okay, these are, so I already explained, right? Beta electrons. It asking subatomic particles in atom. Okay, neutrons, protons, right? What is the relative charge of each of the particle? What is the relative charge of each of the particles? Proton plus. Which of the particles is the most massive? Most massive means beta particles here, right? Which is least massive? Electrons, beta particles. Then move to next one. Determine whether each of the following statements is true or false. If false, correct the statement to make it true. The nucleus has most of the mass and comprises, should be comprises, most of the volume of an atom. Nucleus has the most of the mass and comprises most of the volume of an atom. No, it's wrong, right? Correct කන්න මේක වැරදි නැති කියලා දාන්නකෝ වැඩන්න. Every atom of a given element has, it's wrong. Why? Nucleus is concentrated, right? I mean, mass is concentrated, right? That's the theory. Every atom of a given element has the same number of proton. Correct. Every atom of a given element has the same number of protons, exactly, right? Don't confuse with that. You always get confused about these things in all levels, right? So don't get confused, right? Don't get confused. Okay. Then the number of electrons in an atom equals the number of electrons in an atom equals the number of neutrons in the atom row, right? Right. Number of protons and electrons are equal in a neutral atom, only in the neutral atom. Okay. The protons in the nucleus of helium atom are held together. Protons in the nucleus of helium atom are held together by a force called strong nuclear force. No. Protons of the nucleus of helium atom are held. No, it's not like that. Fourth one. Which of the followings are isotopes of the same element? So here, just, I mean, to become isotope, it's easy, right? To become isotope, it should have same protons. Protons should equals to what? I mean, protons are equal, right? I mean, what should equal? We should, to become an isotope, we don't need to care about the mass. To become an isotope, it equal, should have equal what? Atomic numbers or protons, right? Right. It should have equal atomic number, right? First and third one has 16. Whatever, if it has 16, it's a isotope, and whatever it has 15, just consider. So look at the tube, right? So some elements have 15, some elements have 16. Then the element that has 16 protons or atomic number, right, are isotopes of each other, right? That's it. They are isotopes of each other. Next one, how many protons and electrons are in the following atoms? How many protons and neutrons and electrons are in following atoms? First one, argon 1840, right? Argon 1840. Protons 18. This is O level, right? These are O level. I'll write few and then I'll stop, right? You can do it. මේ වැඩි මං කියලා දෙන්න ඕනේ නැහැ. O level කාලේ ටීචර්ස්ලා කියලා දුන්නානේ. Right, then how many neutrons? 20. 2 neutrons. 18 electrons. 18 electrons. Barium should have 56 protons and then 56 electrons. And how many neutrons? 56, 20, 24 neutrons, right? 24 neutrons. Likewise, you can calculate a carbon, 6 electrons, 8 neutrons, 6 protons, right? Easy, ne? Okay, then again another question, right, which is from those are basics, right? That's why I said, right, I'm just explaining those things. Even sometimes students don't know these things, right? If you know, then it's good, right? This is not O levels. This is not A level. Even O level, these are very, maybe it's bigger in O level. I don't know. How many hydrogen atoms are in each of the following? How many hydrogen atoms are in each of the following? First one, 6 hydrogen atoms. 6 hydrogen atoms. Second one, 3. Third one, NH4 thrice, that means 4 into 3. 12 plus 4, 16. 16, no? Right, then the 7th one also easy, right? 8th one, you can fill it by using a periodic table, right? The element that has 25 protons is the element that has 25. Manganese, the element that has 48 electrons, means should have 48 protons, which is 48. Cadmium, right? Likewise, you can fill that. Okay. Then මෙයාලා නිකන් try කරලා බලන්න මේ කලින් මේව දන්නේම right, already know that. No reason to do one by one, just Google. If you got a small card, I said, then you have that card, right? If you don't have, just download it now. Just tell me, I will send card, right? Then Next one, write the correct symbol with both subscript and superscript for each following use list elements inside the front cover as needed. Okay, platinum that contain 118 neutrons. Isotope of platinum that contain 100 neutrons. First you have to find platinum, right? Platinum PT, right, which has 78. So I'll write one example. PT. So you have to write, just find the atomic number 78 and then 78 plus 118, get the total value. 78 plus 118. 196 ne? 196. So, yeah. Then do the same thing for other questions, right? Do the same thing. Then the next one, what is the mass of AMU of carbon 12 atom? What is the mass in AMU of a carbon 12, right? AMU also 12, right? AMU of a carbon 12 atom is 12, 612, right? It's 12 AMU. Right. Why is atomic weight of a carbon reported as 12011 in the table of elements and the periodic table in the front side of cover of this text? Right. White write as 12.011 if its AMU is 12. The reason is it has it. This is not the only carbon atom we can find, right? There are, there are mainly two brothers of this one, right? It has two siblings, therefore we have to consider about them, right? And we have to get the average atomic mass. So that's why we got 12.011, right? That's why we got 12.011. Okay, then next one, rubidium has two naturally occurring isotopes, rubidium 85, atomic AMU 85, abundance 72, rubidium 87, abundance, okay. Now we have something in A levels. What is the equation? Average atomic mass. How to find it? Relative atomic mass into abundance percent, right? Percent abundance of abundance in percentage. Okay, then what is the abundancy? 85. What is the percentage? In the nature, in nature, 72% of rubidium has the mass, relative atomic mass of 85, 72%. And then what? Next, other one is 87 and the abundancy 28%. Okay. Naturally, 28% of rubidium exists as this atom. Clear? That's the idea. So then do the calculation. Just find the value. That's the atomic mass of rubidium. Get it? Average atomic mass of rubidium. So what is the answer? 85.56. 85.56. Right. That's why in the periodic table we don't get any round numbers, right? I mean, in exams we get most of the time round numbers, right? Only example we get decimal for chlorine, right? The reason for chlorine also this average case, and we never, I mean, normally we say 12, right? But in university level, right, when you go to university or in higher studies, we don't take just 12, right? Because we have calculators, right? We have calculators, so we never get round up numbers. We have to use the exact numbers with decimals, right? So 12.011, right? That's the number in atomic. Right? That's the number in where? In the periodic table. So we have to use that numbers, right? Clear? So when you search the element in Google or somewhere else, then you will get the exact, I mean, the decimal values due to these several atoms, right? We have to consider about these atoms, right? Okay, then next one you can do that, right? 12th one, right? Hydrogen atom, it doesn't matter how many atoms you can find it, just count it. So then each of the following elements is capable of forming an ion in chemical reaction by referring to periodic table. Predict the charge of the most stable ion of each, right? These are all levels, right? So what is the ion formed by magnesium? Mg2 plus, aluminium Al3 plus, potassium K plus, and sulfur S2 minus, S4 minus, right? It's from several ones, right, in A levels. F minus, then right. Next one, 16th, it's okay, right? Just do the formula, right? Just write it using your basic knowledge. And then 17, create the formula, chemical formula for the ionic compounds formed by calcium and bromine, right? For calcium and bromine. So you learn it in O levels, right? But I just remind it in Ca2 plus, right? So here don't never frame two equations, right? So just get the theory, right? So here it's Br minus. You have to balance charges, right? So to balance 2 plus charge, you need how many? 1 minus charge. You need 2 minus charges to balance 2 plus charges. So therefore, how you the one barium, sorry, one bromium ion has 1 minus charge. So then to balance calcium, you need 2 Br, right? CaBr2, right? So then NH4SO4, NH4 plus SO4 minus 2 minus. So here it's 2 minus, this one 1 plus. You need 2 of them to balance this minus 2. NH4 twice. So whenever you don't need to memorize those compounds. I mean, if you couldn't memorize, right, at the end of the, I mean, after you learn this syllabus, definitely you will remember those things, right? But for now, just if you couldn't remember, just form it, just make it, right? You don't need to memorize, right? How to make it. If you know the ion, then just you have to balance the charges, right? That's the theory. Okay, that's it. Then the same theory, magnesium phosphate, Mg3 PO4 2, right? Magnesium. Why do we bracket this one? The idea means two set, right? But here just one element. This one, it's a polyatomic ion. This one just a simple atom, right? I mean ion, monoatomic ion. Then Mg2, sorry, Mg3 PO4 2, right? That's how we balance it. Then 18th one, it asks to write the chemical formula, right? K plus K and Cl, KCl, then NH4 plus and Cl minus, NH4Cl, right? Then Mg and Cl minus, MgCl2, you already know that. Fe3 plus and Cl minus, FeCl, FeCl3, right? Just balance the charges, huh? Then OH minus and K plus. KOH, potassium hydroxide. NH4OH, ammonium hydroxide. Then Mg2 plus and OH minus, magnesium hydroxide. You already know that. Okay, magnesium hydroxide. And then ferrous hydroxide, FeOH3. FeOH3. Right? These are very simple things, right? So you can find the answers, right? Even if you Google it, it's okay. Nothing to teach it. Basically, from all of us, the only difference, you have new compound, new elements here, right? That's it. The same kind of question here, 19th one, and then the 20. Do the 19th one by yourself. Then the 20. Which of the following are ionic and which are molecular? Ionic compounds and Actually, it's molecule means, I mean, basically it's covalent, right? So you will learn it deeply in the future, right? In later, right? Later on you will learn it deeply, but here just simply you will get the idea, right? Basically, the basic idea, elements, when you mix elements from group 1, 2 and group 6 and 7, around 6 and 7, most of the time when you mix, I mean, when you make formulas with first and second, I mean, basically metals, most of the time you will get ionic compound. It's a general idea. There are some exceptions, but the general idea is that. So here you can give the idea, give the answers according to that. Okay, then give the chemical names, right? These are common chemical names. Okay, sodium chloride, sodium bicarbonate, sodium oxalate, I mean, sorry, sodium hydroxide, ammonium carbonate, right? Okay, here then the last one you have, it asks you to write the chemical formulas. Just write it now. KNO3, potassium nitrate, sodium carbonate, right? You will learn these things later, but here this is a kind of a revision for your O level knowledge, and then just to get the idea, right? This is a way we fill the gap, right? So between O level and A level, right? These are not A levels, right? Even a little bit higher than O level, right? Magnesium hydroxide, magnesium sulfate, right? You will learn how those names forms and those things, right, very deeply later. For now, just write the answers, right, using your knowledge. Okay.